In this lesson, we are going to be talking about simplifying and multiplying rational expressions. So the first problem you see here is just a fraction. So we're just going to go review our rules for how we simplify those fractions. So remember that if we're looking at the numbers, 21/14, we would reduce those numbers to 3/2. And then when I'm looking at the variables, I look at the x's and I would say, where's the bigger x? Well, since they're both x squared, they divide into each other one time. So then I'd move on to the y's. Where's the bigger y, top or bottom? Bigger y is on top, so I subtract them. 3 minus 1 is 2. So my answer would be 3y squared divided by 2. When you look at number 2, something obviously crazy happens to number 2. Let's see if we can move it. Okay, let me just fix this because it's shifted for some reason. So ignore that. There we go. Number 2, I can choose to either square everything first or simplify it. I like to follow my order of operations, so I'm going to actually choose to simplify what's in the parentheses first. So I would reduce that 5/10 to 1/2. I look at the x's, bigger x, top or bottom? Bottom. So 4 minus 2 is 2. I look at the y's, and there's just a y on top, so I'm going to put a y on top. And then when I look at the z's, I say bigger z, top or bottom? That would be top. 3 minus 1 is 2. So there is my simplified fraction inside the parentheses. And then when it says to square that, what you're actually going to do is you're going to square everything, top to bottom. So that 2 goes there, and it also goes down here. So I'm going to square 1. 1 squared is 1. Y squared would be y squared. Z squared squared, so z to the second raised to the second power, we multiply those. So I would get z to the 4th. And then in the bottom I have 2 squared, which is 4, and then x squared squared, which would give me x to the 4th. And because I simplified that fraction before I squared everything, that's probably going to be as far as you can go. The numbers could potentially reduce in this problem, but for this case it doesn't. So now that we've reviewed those rules, we're going to actually multiply. Oh, this is going to be annoying. So now when I'm looking at this multiplication, just like when I'm multiplying numbers, if you remember multiplying when you were in whatever grade you did multiplying, 3rd grade maybe, multiplying fractions is probably more like 5th grade. But when I'm looking here and I was going to multiply these two fractions, remember cross-canceling? So that you could simplify it a little bit more, and then you could cancel across, or you could cancel top to bottom. So for this problem, I would also then go like this. And then I'd get 1/2 for my answer. So the same idea applies to the ones we're working on today. So we're going to be able to cross-cancel or cancel top to bottom. As I look, I'm going to see what I can cancel. I can cancel the 8 and the 16, so I'm cross-canceling to make that 1/2. Then I would maybe look at those x's. I have an x to the 1st and an x squared, so I would cancel out one of those. My 7 and 21 can reduce to 1 and 3, and then y squared and y. Remember, if you're not sure why we're doing that, think of this as 2y's and this is 3y's. Remember, isn't that what that means? So as I reduce these, I've got 1 for 1. 1 for 1. So there's just that 1y left over there. So we are subtracting, but that's really where that rule comes from. So now as I look across my numerator, to multiply the fractions, you multiply across your numerator, I have only 1s. So I'm going to have a 1 here. And then when I look at my denominator going across the bottom, I would have 3 times 2, which makes 6, and then an x squared and a y. So I would choose to write that in descending order. And that's my final answer. So I'm going to let you guys go ahead and try number 4. So please pause the video, do number 4 quick, and then you can check your answer with mine. So as I'm doing number 4, hopefully you canceled similarly to what I'm doing. Maybe not in the exact same order, but that looks like all I can do. So as I go across the top, I have a 2, an a, and then I have a c to the 1st and a c squared, which makes c cubed. And then in my denominator, I have a 3 and a b squared. So the 3 and the b squared right there. Nothing reduces here, so that's your final answer. Number 5, then, you'll see that we have a couple of terms in here. We'll have a monomial. This is shifted off, so yours looks good on your paper. I'm not sure why all of a sudden these things are shifting on me. but this one has 3y times y plus 7, and then on the bottom it has y plus 7 times y squared minus 9. Our rule for when we have more than one term, or when we are able to factor the top or bottom, is that we need to factor it in order to see if something cancels. So when we have, like in our last problems, excuse me, we had only monomials, so one term. Now we have binomials in this problem, where things are being added or subtracted. Whenever that happens, we need to factor, if possible, to see if there's like binomials that we could cancel. So in this example, what's considered a like binomial is this y plus 7 and the y plus 7. They're the exact same parentheses. A lot of students will want to cancel these y's only, but remember we can't do that when it's part of an addition or subtraction. So the only way to cancel them is if they're the exact same, like these are, so I'd be able to cancel them here. I do have a y squared minus 9 in my denominator here, and I would look to see if I can factor that, because maybe it would cancel with something up top. So when I factor this, it's a difference of two squares, y plus 3, y minus 3. And that would replace that. And then when I'm looking, I'm seeing if there's another y plus 3 in the numerator, or y minus 3. There's just the 3y, which does not cancel with that. So I would bring that down and write y plus 3, y minus 3. Now in this problem, factoring it didn't help me, but we are going to leave our answers in factored form because you want to reduce them as far as you can to see if anything cancels. If you happen to write this answer like this, and you had re-multiplied, so you FOILed out that bottom and you get y squared minus 9, it's the same thing. I would count this correct. I prefer you to leave it like this, because then I know you got everything as simple as you could, and you check to make sure anything could cancel, and you're not going to miss something, hopefully. Again, some people will want to sometimes cancel those, let me find those y's, like that, or maybe the 3's. And because on the bottom that's part of an addition or subtraction, I cannot do that. That's not allowed to happen because it's being added or subtracted. If there was a random 3 on the outside here and it's being multiplied, those could cancel because that's not part of an addition or subtraction. It's being multiplied, which makes me able to cancel it. And we'll run into lots of examples like that if you're confused by that. So in number 6, here you see that we have a binomial in the numerator and the denominator. So my first step always is going to be to factor anything I can in the numerator and denominator. In my numerator, I see that I have a greatest common factor, which would be a 5. So I'm going to divide both terms by 5, and that would replace that numerator. In my denominator, I also see that I have a greatest common factor, which would be 15y. So when I divide both terms by that, I look at what I have left over. So now when you're looking at this, hopefully you can see that we have like terms in that we have a y minus 2 divided by y minus 2, which we say it cancels, but really when you think about it, y minus 2 divided by y minus 2 is really 1, isn't it? When you divide anything by itself. So in our minds it cancels, but it's really dividing into 1. So what I'd have left is 5 divided by 15y. I'm just going to write that down here. Because this is 15 times y, I can reduce those numbers. So I can say 5 goes into 15 3 times, and my final answer would be 1 over 3y. You maybe would have done that in this step, and that would have been fine. I just wanted to separate it so you weren't confused by where I got those numbers. Number 7, then I want you guys to start that one. See how, well, let's do 7 together, actually. We'll let you do 8. So number 7, again, I have 2 binomials. So when I'm looking at these, I'm going to take out the greatest common factor in both, which in my numerator is a to the 4th. So I have b minus 2 when I divide both by a to the 4th. In my denominator, I see that I have a cubed. So I would have 2 minus b. Now, hopefully you're looking at those parentheses and saying they look really close. That b minus 2 and that 2 minus b look very similar. But they're exact opposites. If you take a look, this is a positive b and a negative b, a negative 2 and a positive 2. When they are exact opposites like this, what I need to do is instead of taking out either in the numerator or denominator, you can choose. I'm just going to pick the top. Instead of taking out an a to the 4th, I'm going to take out a negative a to the 4th, which would then change each sign here because I'm dividing by a negative. And again, now when I look at my b's and my 2's, now they're the same. Negative b, positive 2, positive 2. So really, these are like terms now, and I can reduce them. When I'm looking at my a's, I have a to the fourth divided by a cubed. I say, where's the bigger a, top or bottom? It's on top, so it's just an a left over. So again, because I took that negative out, all I have left is negative a, or the opposite of a, however you want to think of it. And that's my answer for number 7. So now number 8 is similar to that. I want you guys to try number 8. So pause the video, see what you get, and then we'll do it together. In 8, when I take out my greatest common factor, I get 2x squared. So I'd have x plus 3. And then in the denominator, I would actually probably choose to take a negative 6x out, just because I see that negative sign in the beginning. So then I have x plus 3, because a negative divided by a negative is a positive. And this one's a little bit easier, because I think it was obvious to see that you take out that negative. So those x plus 3's reduce. I can reduce the numbers. 2 goes into 6 3 times, so I'll just keep the negative with the 3. My x's, do I have a bigger x, top or bottom? Top. That reduces into 1. So my final answer would be x over negative 3. You also could write this as negative 1/3 x, or negative x over 3. There's lots of ways you could write that and it'd be the same answer. So hopefully that one made sense to you. The last two that we're going to do, you'll see, are trinomials. So we're going to have to factor each numerator and denominator, top and bottom, top and bottom. If you remember when we were studying factoring and I said we're going to get to some problems where you have to factor like 4 times in one problem, here's the problems right here. Because we have a trinomial in both numerators and both denominators, we're actually going to be factoring 4 times for this one problem. So we'll just start and dive right in. I'm going to work on the top numerator here. So I'm going to do my factors. Factors of negative 6 when added together make negative 1, would be negative 3, positive 2. And hopefully you have worked with factoring enough where you are quick with that and you can do it that quickly. Some of you will take longer just because you're not as good at factoring, or it was a harder concept for you, so these problems will just take you a little bit longer. By the end of this chapter, though, you should be very good at factoring. So my denominator here, then, I'm looking for factors of 3 when added together make 4. I would say that's 3 and 1. Over here, I have factors of 2 when added together make 3. So I'm going to say 2 and 1. And then in my denominator, I have factors of 15 when added together make negative 8. So it would be x's. They're both going to be minuses, so let's go minus 5, minus 3. And then we'll throw some pens around. So check those and see that you got the same thing when you factor them. If you have any questions on those, make sure you ask me tomorrow. So now that I am fully factored, I can reduce anything that is a similar binomial. For example, I have an x minus 3 and an x minus 3. So I can reduce top to bottom or left to right. The other thing I would reduce is x plus 1, x plus 1. Now these x plus 2's I can't reduce because they're both in the numerator. And then it doesn't look like I have anything else that cancels top to bottom or left to right. So I would write my answer as x plus 2, and since I have 2 of them, I'm going to write quantity squared divided by x plus 3 times x minus 5. And there's my answer for that problem. Hopefully that made sense to you. So number 10, you can see that we have a little bit of more work when we're factoring on these. Our first one here, we have a coefficient in front of that x squared, which is a 3. So we're going to have to see, first of all, we look always and see if there's a greatest common factor, which there isn't in this one. I'm looking at my numerator here. So I'm going to try to factor factors of 3x squared would be 3x and x. And then I'm going to try and find factors of 6 that could make it equal 11. So I'm looking at 1 and 3, and then 1 and 6, 2 and 3. They'd both be positive. So let's just see what would multiply here. 3 times 2 is 6, plus 3, that makes 9. 3 times 3 is 9, plus 2, that works right there. So I'm going to do a 3 and a 2. So double check here. If you look at my outsides, it'd be positive 9x. And if you look at my insides, it'd be positive 2x. That does work out to be a plus 11x. In my denominator here then, I look first for a greatest common factor, which I do have. It's 4. So I'm going to divide each term by 4. And then I also have to look and see if anything else factors. So I'm looking for factors of negative 2 when added together make negative 1. So that'd be negative 2, positive 1. And that one's fully factored. So now I'd like you guys to pause the video quick and see if you can get the next 2 factored for me. So hopefully here you took out a greatest common factor, and then you would factor into x plus 2, x plus 1. And then down here you have x plus 3, x minus 1. So now in our last step, since we have everything fully factored, we're going to see what we can cross cancel. So I'm looking at, what can I cross cancel? I have an x plus 3 and an x plus 3. I have an x plus 1 and an x plus 1. What else? Oh, look at, hopefully you guys found my mistake. Right here, looking at my factoring. Let's start this one over here. This one, when I took the 2 out, I've changed my sign. Aren't you excited that you thought you got me on one? That was close. Here, when I factor, then I would get x minus 2, x minus 1. So now I'm going to have to look again at my, let's get rid of this. Let's just start our factoring over, or our canceling, excuse me. There we go. Does that look better? So now as I go to cancel, I still have the x plus 3's, but now I have these x minus 2's, and then these x minus 1's top to bottom can cancel. My outside numbers here, my 2 and my 4, I can reduce. So this is a 1, and this is a 2. So now as I'm looking, it looks like I don't have much left. Nothing left to cross cancel or cancel top to bottom. So all that's left in my numerator is 3x plus 2, from right here. And then my denominator is right there, so it'd be 2 times x plus 1. And there's my answer. If you chose to distribute that 2 on the bottom, so you have 2x plus 2, same idea. And remember, we aren't able to do that and cancel those 2's because they're part of an addition or subtraction. So I would leave my answer just like this. I actually prefer you to do this one right here, but it's your choice. So if you have any questions on that lesson, make sure you let me know tomorrow.